Hi, I'm going to go over some Pythagorean theorem stuff. This may be stuff you saw in class. Maybe you didn't. Maybe you weren't there. Maybe you missed it, but you're watching it now. So buckle up. Let's see. We're going to share this screen. So this is a Desmos that I don't think I have assigned yet, but if you've seen it, at some point you may want to come back and see it. And what just happened? There we go. The idea is you're supposed to try multiple problems, and the first problem is you've got 8 and 6, and the idea is you're supposed to figure out what the missing side is. So first of all, my guess is something bigger than 8. But once again, our rule here is a squared plus b squared. I'm doing this with my finger, so it's a mess, equals c squared. And so these are what are called our legs. These two short sides. These is a right triangle, and this is always our c, which once again the name for our long side in a. Oh, I'm writing it out. I'm just noticing it. It's up at this top of the screen there. Hypotenuse. There it is. The long side always hypotenuse, whereas these down here once again are called the legs. So I've got two legs. I should be able to plug in those numbers and figure out how long that number is. So 8 squared plus 6 squared equals c squared. That one I know, 8 times 8 is 64. That's what the little 2 means. And then the 6 times 6, which is what that means. And your calculator should have that button on there, and you should figure out where that is. But you could always do 8 times 8, 6 by 6 equals c squared. And that's 100 equals c squared. And this is where some people think to undo the square, we're going to divide by 2, but that's not what that means. That means something times something equals 100. So to undo that, we do what's called the square root, because the square root asks what times what is this number. So when I ask that question over here, what times what is 100, put that in my calculator, or I happen to know that, it's 10. And then on this side, these are inverse operations. So just like if we were doing 2x equals 10, the multiplication to undo it, we divide by 2. Those are inverse operations. That just becomes x, and that becomes 5. Down here, the c squared and the square root, well, those cancel each other out, so I'm just left with a c. And I'll probably, for the rest of these, I'll probably use an x rather than a c. I don't like a, b's, and c's because they look a little weird. So my answer there should be, I'm going to clear off my screen here, if I can remember how to do that. No, there we go. They're all drawings. Okay. So the way to do that is, so that should be 10. And then it says correct, and it gives me, I can get another problem. And so it gives me another one, 24 and 10. I can do that the same way, but that's a little too easy. So we're going to go to the next problem. I'm up in the corner here. I don't know if you can see me. It's probably a blacked out screen. Let's see. So the next one, same problem, but notice now I have a hypotenuse here, and I have a number here, and this is actually to scale. So just by looking at this picture, I'm going to guess this number down here is maybe, I don't know, 15. I'm just guessing, but it's got to be less than the 34. And if this is to scale, which it is, it's got to be less than the 30. So that's my guess. But once again, the way we do this is we're going to say we know a squared plus b squared equals c squared. I have my hypotenuse. It's 34. Got to put it in the right place or I'm going to get the wrong answer. Doesn't matter which one is A or B. I'm going to arbitrarily say this is my A. And then, like I said, I'm going to change my B to an X. I just like using X's better. So one extra step here. 30 times 30. That one I know. That one is 900. I do not know what 34 squared is, so I'm going to kind of cheat here. I'm going to go to the calculator and say, what is 34? I'm going to do shift 6, which is the little caret. And it tells me, oh, that's 1156. So that's not my answer. I'm just using the calculator there because I want to show you. And that's a nice trick to know. So that's 1156 plus x squared. And then the last step is I'm going to minus 900. Well, not the last step. There's an extra step here because I got to get x squared alone. So I can almost do that in my head, but just to double check, I'm going to cheat again. I'm going to say, okay, I've got the 1156. Let's subtract out the 900. That's 256, which I probably could have done in my head. So that is 256 equals x squared. I'm running out of room, but once again, I want to undo the x squared. So I take the square root, And once again, this is a trick that we learned in class. You should have learned in class is, oh, I don't know what the square root of 256 is. I can type in SQR, right? Watch what happens when I hit T. it turns into a little square root. And then I'm going to say 256, and it's going to tell me, oh, that's 16. And now I can, so my 15 wasn't a terrible guess. So let's check that. Yes, keep going. So I could do, do another problem now. Similar kind of problem, different numbers. But once again, that's a little easy. So we're going to go to the next slide. I'm going to clear out these annotations. Okay, so now we got 23 and 32. Now this looks like the first problem. The difference here is, I'm guessing, because I've done these problems before, this number is not going to come out to a whole number. When we get three of the same, like whole numbers, like 3, 4, 5 is a really common one. That's got a Pythagorean triple where all the numbers are whole numbers. That doesn't actually happen that often. So in this case, my third number is going to probably be a decimal. In fact, it's probably going to be an irrational number. So let's try this one. So once again, I'm going to go straight into the equation. I know that 23 squared, which is one of my legs, plus the 32 squared, which is my other leg, has to equal my hypotenuse squared, which I'm going to put as an x. And before I even start, once again, I'm going to kind of guess. This looks to scale. I'm going to guess this is 34. That is my guess. Okay. Let's see if I'm right. So, okay, I'm gonna take advantage of the calculator again. 23 squared is 529. So I'm going to put that in there. 529. And 32 squared is, and once again, on a regular calculator, you could find the square button, or in this case, like you do 32 times 32, that's the same thing as 32 squared. So that is 1024. So 1024 equals x squared. And I'm going to add those two together. And because those are kind of big numbers, I'm going to use the calculator and say that plus the 529. And that's 1553. So 1553. And I certainly don't know what the square root of that. I don't know what times what is equal to 1553. So I'm going to take the square root of both sides. My inverse operation, the square and the square root cancel each other out. And then I have to figure that out. And then because I've got the magic calculator here, I'm just going to put that in there. SQR, magic T, and say 1553. And it's going to tell me, oh, it's a O. So my guess was not great. 39.408. Let's see if it's right. Now, if you wanted to, you could round this to 39.4. I would not round it to 39 because it makes it look like it's in a Pythagorean triple, which it's not. And notice the little double squigglies. It's like a wavy equal sign. That means approximately, because there's more digits after this. This goes on forever. This is an irrational number. So I could leave it like this, or I could round it. I'm going to just leave it like this. But once again, if I put in 39.4, it should check. And actually, I want to show you that 39 probably doesn't check. So 39, check. Not quite right. But if I put in 39.4, guessing it's going to check. Yeah, that was, yeah. So the 39, little too much rounding. So that's the 39.4. Okay. And then I could do another problem. Similar kind of problem. And I can do this really quick. I can do this really quickly now because I know that I'm going to do 11 squared, which is 221. And I know I'm going to do 5 squared, which is 25. And then notice it's adding it all up for me. And all of that, I'm going to do the square root of that. So 146 square root of 146. And it's 12.1 roughly. If you rounded that one to 12, you might get away with it. And then that one's right. Okay, let's clear this out. Let's see what these get any harder. Okay. Oh, okay. This one I have not shown in class yet, so this is new. But the idea here is the same. So we have a number that's 3 times square root of 51. Okay. Now, if you put 3 times, and then that's what that means, 3 times. So if you figure out what the square root of 51 is, which is 7 point something, and you multiply it by 3, it gives you a number. And you can certainly do it that way. But I want to show you the other way that you might do that. Plus 5 squared equals x squared. And once again, just to check, let's see, let's get a sense of what that number is. So square root of 51 is 7.143. Okay. And if I multiply that times 3, so this thing is about 21 long, 21.4 long. And if I use 21.4 I'll get an answer that's close, but I want an answer that's exact. So I'm gonna not use the 21.4. I'm gonna say I know that I am basically squaring the 3, and I'm also, so this is a little bit like distributive property. I am going to also square this. Well, 3 squared is 9. There's a little times in there. Times square root of 51 squared. Anything, the square root of anything squared is itself. So once again, square root of 4, which is 2. If I square that, well, 2 squared is 4. Oh, it's the same thing that's under there. Anytime you have a square and a square root, it's whatever what's called the base is. So I know that's going to be times 51. And now I don't have to do any rounding. Notice I had that decimal number in there before. So this is plus 25 equals x squared. And so that is 9 times 51 is 459 plus 25 is 484. So oops, lost my writer. 484 equals x squared. And then I want to take the square root of that whole thing. So square root of that, whatever that answer is how long that thing is. And so once again, this was about 21. This is 5. I'm going to guess this is 22 before I do any work at all. Square root of 484. Oh, exactly 22. Good guess. That was literally a guess. But if you had done the 3 times the 51 and done all this with the decimal number, you would get a number that was really close to 22, but it might be like 22.01 or 21.99 or something like that. So this is the advantage of not doing the 3 times the square root of 51 first, but knowing this little trick of, oh, square root of 51 squared is 51. I still have to square the coefficient out front, but then I can multiply those two together. Okay. Let's clear that out. Oh, I didn't check that yet. Check. Yes. And then I can get another problem. And then it gives me another problem, kind of a simpler kind of problem. Let me do one more of those because those were a little complicated. So let's clear that out. So once again, I have 6 squared. If I can draw. 6 squared is one side. The other side is 6 square root of 15. And we're going to square that number. And that's equal to the hypotenuse squared. Now, just to give you a number sense here, I don't want you to do it this way, but it's important that you know that 6 times the square root, SQR, magic T, 15, is about 23.2. So I could put 23.2 in here and do it, but I'm losing some of my information here, and I'd rather not lose that 379. And once again, this goes on forever. So this is where we like to do this trick. We like to say that, oh, well, that's the same as 6 squared times square root of 15 squared, which is basically 36 times 15. And now I haven't lost any information. The decimals that I chopped off there a minute ago are still there. So now I just have to figure out what's 36 times 15. I'm going to add 36 and then take square root of the whole thing. So my 36, which is my 6 squared, and 36 times 15 is 426. And then I'm going to take the square root of that whole thing. I'm not going to finish doing my work on the side here. So square root of 426. So before I do that, I'm going to guess, because that was about 23, but maybe 25. I don't know. And I've forgotten what my number was. So I'm going to show you a trick. I forgot what my number was. 6 squared plus 6 square root 15 squared. Oops, I got to put it in the right place, so it won't give me the right answer. No, it's 24. So that's exact. 6 squared is my 36. My 6 square root 15 is whatever the 36 times 15 was. And then I've got it all in the square root. So that's right. Okay, let's see what we got left here. Somewhat random. Okay, this is just review. So let's clear everything out. So take a moment to see if you can't figure out what this thing is. First, come up with a guess, what looks reasonable, and then see if you can't figure out what that is. All right, so 2 squared plus x squared equals 6 squared. So 4 plus x squared equals 36. I'm going to subtract 4 from both sides. I've got x squared equals 36. And I'm going to take this, 32, mistake. Square root. And so whatever the square root of 32 is what I'm going to put in there. And my guess is maybe 4-ish. No, it can't be 4 because 2 plus 4 is 3-ish, 3.3. I'm making that up really quick. No, that can't be right. It's got to be more than 4. Oh, 5-ish. Yeah, 5-ish is what I'm guessing. Square root of 32. 5.6. 5.7 is what it kind of rounds to. Okay, and then it gives me another one. Oh, no, that's a very different one. So let's take a look at that. I wasn't expecting that to come up. So let's clear this. So this is, I know that 6 square root 15 squared plus something squared is equal to square root of 5/7. Now this looks like a hard problem. This is actually an easier problem because the square root of 576 squared is just 576. That's what that is. We already kind of did this one over there. So I'm going to do this kind of quickly in my head. I'm going to say, well, I know I'm going to eventually subtract, I'm eventually going to subtract this from both sides. So I'm just going to do it up in the calculator up here. I'm going to say, well, I know I've got 576. I want to subtract out whatever 6 square root, oops, I got to type it right, SQRT, nope, SQRT 15 is, I got to remember to square that number. And then I'm going to, 36, which I'm like, that's got to be 6. Now, it's hard to know that the 6 is right without having some sense of how long these things is. 6 square root of 15, I think we decided was about 23. And I don't know what the square root of 576 is. But 36, square root of 36 is going to be 6 because I know my square is less than 12. So that should be 6. Yay, keep going. And that gave me another one. Okay, let's see what's one last one. So this is a good one to end on. So the basic idea here does not change, and you could do this with a calculator and it will always get you right, but I'm going to show you how you don't really need a calculator for this one, or probably don't need one, at least until the end. So once again, we have one side is square root of 3. Now I know square root of 3 is about 1.7 because that number comes up in math a lot. Plus, I don't know is my thing right there. And this is the 103. So 103, square root of that is going to be 10 point something. It's a little bit more than the square root of 100. So square root of 103 squared. Now look how this turns out. Okay. Square root of 3 squared is 3. Oh, that should have a square on it. Plus x squared equals 103. I don't know what just happened there. Oh, shoot. Somehow I think I got off that window. Okay. And then finally, I'm just going to subtract 3 from both sides. Look at that. X squared equals 100. This one was easier to do without a calculator because I know the square root of 100 is 10. And so if you think about this, this was about 1.7. This was about 10.1, I'm guessing. So the 10 makes sense there. Slightly less than the hypotenuse. Those are very close to the same length. All right, so we're just going to put our 10 in. We're going to check it. Okay. And then the idea for this particular one was it tells you, how many you've done of each and to try to just do as much practice as you can. There's some more instructions out here that you should have seen on a previous Desmos, but I will mention that, I think, at the very top, that if you're doing this Desmos, well, actually, I would just go back and review it. So you watch my video. Okay, thanks for watching. Just figure out how to stop recording. Where's stop recording? Pause, stop recording. Okay, ciao.